Okay guys, so today we are starting proofs. So we're going to start with algebraic proofs. It says 2425 down here, but it's going to be just 24, and in class we're going to do the 25. So let's go ahead and get started. All right, so this is going to be a lot of writing for you today, but you have to know your properties, basically is what it boils down to, okay? So the very first property we're going to look at is the addition and subtraction property. And of course, I spelled that wrong. Subtraction. Okay, there we go. So the addition and subtraction property says that if A equals B, so if two numbers are equal to each other, then if I add some random number C to both sides, they're still going to be equal. So that's why whenever you add a 4 to both sides, the equation stays equal. And the same rule applies to subtraction. So if A equals B, then A plus C equals B plus C, and A minus C equals B minus C. And you will see this in action when we actually start doing the solving. Okay, multiplication and division is the next property. And if A is equal to B, then A times C equals B times C, and A divided by C equals B divided by C. So notice that if A is equal to B, so if they're the same number and you multiply both sides by the same number, they're going to stay equal. I mean, it's kind of common sense. The next one is substitution. Substitution, you know, when you substitute something in place of something else. So what it looks like is if A is equal to B, then A, and I am going to actually put quotations around A. So I can take the letter A and I can substitute it in place for B in any equation or expression. Okay, so I'm just going to replace, if A and B are the same number, then I can replace them with each other because they're equal to each other. All right, the next one we have, okay, this one is distribution. You know this one, distribution. Okay, so if A times B plus C, so it's going to be equal to, so you know the drill. So when you multiply, so let me make sure that we've got a skinny pen here. So if I take the A and multiply by B, I get AB. If I take the A and multiply by C, I get AC. Okay, so it works the same. All right, reflexive. Now reflexive is new, and I want you to think about a mirror when you hear reflexive, like reflection, okay? In other words, something is equal to itself. A equals A, B equals B, X equals X. So reflexive is when something is equal to itself. Okay, the next property is symmetric. Symmetric is when they trade places. Okay, so if A is equal to B, then B is equal to A. You know how whenever you're solving an equation and maybe you get down and it says, oh goodness, you get down and it says X equals, or 4 equals X or whatever. So maybe we get down and it says 10 is equal to X. Well, we know that it's the same thing as X equals 10, okay? So it means the same thing. Doesn't matter what side it's on, but this property is what allows me to be able to say that. And then the next property is the transitive property. It's very similar to the law of syllogism, okay? So in this property, if A is equal to B and B is equal to C, notice here that both A and C are both equal to the B. So the B is going to cancel out and you get A equals C. Okay, so now what we're going to do is we're going to look at each one of these examples over here on the side, and we're going to choose the property. So it says name the property that the statement illustrates. So if X divided by C equals 7, then X equals 14. Oh, that's a 2. Okay, sorry, X over 2 equals 14. So basically what's going to happen here is if X divided by 2, what's the opposite of dividing by 2? Multiplying by 2. So if I multiply both sides by 2, and that should be a multiplication, this thing is not cooperating today, then I know that I multiplied, so that is the multiplication property. And that's all you have to do. It's like for every step, there is an actual property that says it's allowed. Lots of rules. Okay, if xy is equal to wz, then xy minus 4 is equal to wz minus 4. So how did I go from here to here? And I'm not real sure what's going on here. So how did I go from here to here? Well, I subtracted 4 from both sides. So that is the subtraction property. And this thing is really giving me some serious grief today. All right, so I had an xy, and then it became xy minus 4, so that means I subtracted from both sides. Here, if 2 times x plus 3 equals 12, then 2x plus 6 equals 12. So all I did to go from the if to the then is I distributed the 2. So this is the distribution property. So do you kind of see how it works? Okay, if EF equals GH and GH equals JK, so notice both of these things are equal to this GH. So that means the GH is going to cancel out. So EF is equal to JK. This is an example of that substitution. Well, actually, this is the transitive property. Substitution is a little bit different, but it does work the same. So this could be substitution, and I'm going to go ahead and put it on here. This could be substitution or transitive. So this is the substitution or the transitive property. Either one will work. All right, because I substituted it in place, or actually transitive works better here. I'll show you a better example of substitution. So let's just do that. Let's just say this is the transitive property. All right, if JK is equal to KL and KL is equal to 16, well, then JK is equal to 16. So what I'm going to do, I'm going to call this one substitution. This is a much better example of substitution, and I could have very well gotten them backwards when I was making this. So if JK is equal to KL and KL is equal to 16, then I'm going to replace, I'm just going to go over here and I'm going to replace this KL with 16 because that's what it's equal to. So now I know that JK is equal to 16. So this would be substitution. This is transitive. But notice how similar they are, and they are sometimes interchangeable. Okay, ZY equals ZY. This guy's looking in a mirror. This is the reflexive property. Good gravy. And if PQ is equal to ST, so ST is equal to PQ. Notice they just switched sides. This is the symmetric property. So when they're equal to their self, it's reflexive. When they trade places, it is symmetric. All right, so now let's use some of these properties. So a proof. A proof is a sequence of statements that uses definitions and properties to show that a statement is true. So there are 3 kinds of proofs. We're going to focus on 2-column proofs, okay? So 2-column proofs are what we're going to focus on. 2-column proofs, they have numbered statements and corresponding reasons, and they show the order in it shows the argument in a logical order. A paragraph proof is statements and reasons written in sentences like a paragraph. We're really not going to do anything with these, but you do need to know that paragraph proofs exist. Then there's a thing called a flow chart, and it uses boxes and arrows to show the flow. Don't use these either, but they are forms of proofs. We're just not going to do them. We're going to stick with these 2-column proofs because they're much easier. All right, so here we're going to look at this. So when you are writing a proof, you need to understand that there's always going to be something that's given, okay? This given information. So you have to take the information that is given and you work towards what you're trying to prove. This is what I'm trying to prove, okay? So in an algebra proof, it's a little easier to visualize. So what we're going to do is we're going to take this 3x, goodness. All right, we're going to take this 3x plus 2 equals 23 minus 4x. So what I do know is this is given. So since this is the very first thing, then I'm going to go and I'm going to say, well, I'm writing this down because that was given. So your first reason is always going to be given, and the first statement will always be what is listed after the word given. So this will always be number 1. Now, Here, the next thing I'm going to do is, if you'll look here, they have 3x plus 4x plus 2. So what they did is they said, I'm going to add this 4x to both sides. Now we write it this way, they're writing it like that. It's the same thing, okay? So what they did is they used the addition property so that they could add that 4x to both sides. Now the very next thing they have is 7x plus 2 equals 23. So here what they did is they combined like terms because I added the 3 and the 4. Now the next thing we're going to do is I'm going to subtract this 2. So I have 7x equals 21. So what did I do? I subtracted the 2. So I'm going to subtract a 2 from both sides, and that is the subtraction property. And then last, I have the 7x, so I'm going to divide by 7 so that I can get my answer, which is what they want me to prove. So the very last step that I did was division, so I used the division property. So every time you do a step, you give me the reason why that step happened, okay? You will never, ever, ever use this word over here. This right here will never be used. This is the direction. This is what you're trying to do. You're trying to prove something. It will never be a reason, okay? If you put it as a reason, then the whole thing is wrong. All right, so let's look at this one here. So given, okay, so we're going to take the given information, which is -5 times 7w plus 8 equals 30. So I'm going to take that, and my reason is that it is given. Okay, this is always going to be the first thing. Now the next thing, I'm going to distribute that -5, so I get -35w minus 40 equals 30. That's the distributive property. Then the next thing I'm going to do is add the 40 to both sides, because if it's negative here, then I'm going to have to add it over there. So that's the addition property. And then last, it says -35 times w, so the opposite of times is to divide. So you're using the division property. Now I'm going to show you all the steps here so you can see them. So 7w plus 8 equals 30. So we got -35w minus 40 equals 30. So I'm going to add this 40. So that's where that step came. So now -35w. Let's see if I can move this thing because it's kind of weird today. Over 70. And then I'm going to divide by that -35. Cancels. So now I've got that w is equal to -2. And that is what we were trying to prove. So there it is. Okay. So we are going to do quite a bit of these in class so that you can practice. And we're going to look at what happens whenever these are actually more than just algebra. Okay. So we're going to look at what happens whenever we have segments and angles also. Okay, so make sure you put stars by anything that you're confused on so we can ask about them in class and make sure everybody understands everything that's going on. So I will see you guys later. Have a great day.